have discussed about the three different type of language. One is called the low level language, and that is also called the machine language. Okay. So first one is your low level language and also called the machine language. Second one is your assembly language, and third one is your high level language, that is normal like your English language. And C language come under the high level language. Okay. C, Java, Python, whatever the language currently we are using will come under the high level language. And if you are going to convert the high level language to low level language, we need some translator. Okay, so in the C language, we are using one compiler that will convert the high level language to low level language. So first it will check if there is any syntax error present in your C language or not. If there is no any syntax error, automatically it will convert to the .exe file. But when you are running in the 1.2 system, it will also create the object file as well as the .exe file. So that we'll see. That we'll see what do we mean by object file and what do we mean by .exe file. But basically, both are in the terms of low level language. Both are in the terms of low level language. Clearly? Okay. So nowadays, whatever the compiler is coming directly, it will convert to the high level language to low level language. But previously, whatever the compiler we are using, first it is converting the high level language to assembly language. Then we are using the assembler to convert the assembly language to low level language. To convert the assembly language to low level language. Clear? So anyone, any doubt in this three language, low level language, assembly language, and high level language? Anyone, any doubt? Any doubt? Okay, no doubt. Now you can see, first I'm going to do a little bit about the binary system. Okay, because the computer can only understand the binary system. That will only understand the 0 and 1. Okay. So I think you are very much comfortable with decimal system. If you are writing decimal 587, we are also writing 989, something like that. 987, something like that. This is your decimal system. What do you mean by decimal system? Is your base is your 10. Okay. So when you are writing the base equal to 10, the maximum you can write here 9. In a single place, maximum you can write 9. As for example, if you are writing the base equal to n, in a single place, maximum you can write n minus 1. You can write 0 to n minus 1, but you cannot write n. If you are getting the n, you will write in the two different places. So as for example, if you are talking about the base 5, base 5 means here whatever the value present in base 5, all the value will come 3, 2, 0, 1, 4, 6. You cannot write because this is not possible in the case of base 5. In the case of base 5. Same like that in the decimal, you are writing the 10. In the single place, you can write either 0 to 9. Same like that, if you are talking about the binary system, the base is 2. What is the value you can write in the single place? What is the value you can write in the single place if the base is 2? Because I have already mentioned in the decimal system, base is 10, but in the binary system, base is 2. If you are writing the octal system, base is your 8. Okay, so here you can only write 0 or 1. In a single place, you can only write 0 and 1. Right? You can only write 0 and 1. Okay. Now you can see, first we'll see only the simple procedure how to convert any decimal to binary and how to convert the binary to decimal. Okay, binary to decimal. Okay. Now, if you are writing here 987, can we write the same term as 7 into 10 to the power 0 plus 8 into 10 to the power 1 plus 9 into 10 to the power 2. If this is a decimal number and the base is 10, can we write this number in nothing but equal to 7 into 10 to the power 0, 8 into 10 to the power 1, 9 into 10 to the power 2. Can we write? Can we write? If you are going to solve this expression, what value will get? 7 into 10 to the power 0. What is the value of 10 to the power 0? Anyone? 10 to the power 0, what value will get? 1. So we will get 7 plus 8 into 10. What value will get? 80 plus 9 into 100 will get 900. So total we are getting 987. Okay. Same like that, just you can see this is a very important point here. If you are taking any number, just try to understand what I am writing here. X1, X2, X3, X4, X5 and base is your n. X1, X2, X3, X5, base is your n. The first one, whatever the value you have written, X1, X2, X3, X4, X5, all value come smaller than n. first, because the base you are writing n means the maximum value you can take for any x1, x2, x3, x4 and x5 n minus 1. You cannot take more than n minus 1. Now after that, simply you have to give some number, position 0, 1, 2, 3, okay, 0, 1, 2, 3, 4. If you are going to convert this value to some decimal number, if you are going to convert the base n to decimal number, the procedure is you have to write x5 into n to the power 0 plus x4 into n to the power 1 plus x3 into n to the power 2 plus x2 into n to the power 3 plus x1 into n to the power 5. Okay, simple term. If you are writing 1 0 1 1 0 base 2, can we say this is a valid number? Okay, second one 1 0 2 1 0 base 2, can we say this is a valid number? Can we say this is a valid number? No, this is not a valid number. Can we say this one your valid number? Can we say this one your valid number? Yes, this is a valid number, because whatever the value present inside this box, all the value is coming less than 2. Okay. Now, if you are going to convert this value to some decimal number, what is the procedure? First, you have to give the notation 0, 1, 2, 3, 4. Okay. First position, what is the value? 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 plus 0 into 2 to the power 3 plus 1 into 2 power 4. Now we will find what is the value we will get? 0. This value becomes 2, this value becomes 4, this value 0, and this one is 16. 16 plus 4, 20, 20 plus 2, 22. So if you are going to give the input as a 22, actually the computer will store 1 0 1 1 0 1 0 1 1 0. Now we'll try one more number 1 1 0 1 0 0. Can you tell me what is the value? Anyone? What is the value? 1 1 1 0 1 0 0. What is the value? Just will use the simple formula, you will get the answer. Okay. So some students have already calculated the value. We have to write 0 1 2 3 4 5. 0 1 2 3 4 5. Okay. 0 1 2 3 4 5. Okay. Now here you can see how will you start. First one, your 0 into something 0, 0 into something 0. So we will write 1 into 2 to the power 2 plus 0 into something 0, 1 into 2 4 and 1 into 2 5. What is the value it will come? 32 plus 16 plus 4. What is the value we will get? 52. Okay, 52. Okay, clear? Now the question is, I have already mentioned. Okay, now we do that if you are taking only 2 bits number, because in the computer we are using the term called bits. Bits means one single box. Okay, here you can either store 0 or 1. But if you are taking 2 bits number, what is the minimum value we can store and what is the maximum value we can store? Anyone? If you are taking simple 2 bits number, what are the possible combinations we can write? 0 0 0 1 1 0 1 1. What is the value of 0 0? Anyone? 0. And what is the value of 1 1? 1 1. What is the value of 1 1? 1 1 each. What is the value of 1 1? Not 4. It will come 3. If you are taking 0 0 to 1 1, it will store 0 and 3. Same we are taking the 3 bits. If you are taking the 3 bits number, then what is the minimum value we can store? These are the possible combination we can store. 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Now you can see what is the value of this minimum 0, and if you are going to calculate this value, it will come 7. Okay, are you going to find any type of pattern here? If this is 2 bits, can we write this value? Maximum value is 2 to the power 2 minus 1. Same like that. If this is 3 bit, the maximum value can be write 2 to the power 3 minus 1. If this is n bits, can we write the maximum value can store 2 to the power n minus 1. Okay, maximum value can store 2 to the power n minus 1. Okay, so up to here, anyone has any doubt? If you have any doubt, then again I will explain. Okay, this is a simple one. We will discuss more detail when we will discuss about the number system. But up to here, anyone, any doubt? Just you can use your chat box. If you have any question, you can use your chat box. Yeah, base means basically the number. Just you can see. So when it will come to the decimal system, it base your 10 because we are writing the 10 different symbol. We are using the 10 different symbol. We are using the 10 different symbol. What are the 10 different symbol? We are using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Before the decimal system, we are also using the single base. If you have the 5 books, we are writing like that 1, 2, 3, 4, and 5. If you have 6 books, we are writing the single bit because we have the single what we can say single unique value we are getting. So this is called the base number 1. After that, in the computer system, it will totally handle the 2 different symbol. One is called the 0 and 1, that will consider as a base 2. If you are going for the base 8, it will take the 8 different symbol. What are the different symbols? 0, 1, 2, 3, 5, something like that. Okay. Yeah, so this is the formula. This is the formula. Whatever the formula I have given you, this is the approach that is used to convert any base to the decimal system. Because we are very much comfortable with decimal system. In the real life also, we are using the decimal system. We are not using the binary system. We are not using the octal system. We are not using the hexadecimal system. We are not using the base 5, base 6, base 7, something like that. We are only using the decimal system. So that the first formula, whatever we have discussed, that is only used to convert any base to decimal system. So as for example, someone will ask 5, 4, 7, 2, base 7. Can you find what is the decimal value? Anyone? What is the decimal value? Anyone? What is the decimal value? Right. This is not possible. Why? Because this is not a valid number. If you are writing base 7, we cannot write 7 here. Okay, that is not a valid number. We can simply say this is not a valid number. Okay. Now 5, 4, 3, base 6. Can we say this is a valid number? Can we say this is a valid number? 5, 4, 3, base 6. Yes. What is the decimal value? What is the decimal value? 3 into 6 to the power 0 plus 4 into 6 to the power 1 plus 5 into 6 to the power 2. Just we will solve this expression, we will get the decimal value. We will get the decimal value. We will get the decimal value. Okay. I have already mentioned the computer can only understand the binary value, it will not understand the decimal. Okay. Now we are talking about the memory system. Memory means what is the memory in your computer. So if you are going to store any data for future, if you are going to store any data, we always use the memory. We always use the memory to store the data. So there are basically 2 types of memory. One is called the primary memory and second one is called the secondary memory. Okay. So one is called the primary memory and second one is called the secondary memory. Okay. Okay, why this value will not exist? Some students are asking like that. 7, 8, 9, and if you are writing base 9, why we can say this is not a valid number? Anyone? Just you can use your chat box. Why we can say this is not a valid number? What is the logic of 9? You can put maximum here in a single place. You can put maximum. What value you can put? Maximum 9 minus 1 is maximum 8. Maximum 8. Okay, same like that. Now assume that if you are talking about the base 16, what is the value we can put in the single position? If you are talking about the base 16, what is the maximum value we can put? 15. But 15 can be right in the single position. 15 can be right in the single position. No. So in this case, if you are getting 10, we have to write A. If you are getting 11, we have to write B. If you are getting 12, we have to write C. If you are getting 13, we have to write D. If you are getting 14, we have to write E. And if you are getting 15, we have to write F. Okay. So that we will discuss. That we will discuss more detail when we will discuss about the number system. Then we will discuss about the number system. Okay. So first we are talking about the memory. There are 2 types of memory. One is called the main memory or also called the primary memory. And second one is called the secondary memory. Okay. Primary memory means the CPU can only access the data present in primary memory. It will not access the data present in secondary memory. So if the CPU is going to execute any instruction or any instruction, then in this case, first it will check whether the data is present in your main memory or primary memory or not. If the data is not present, then in this case, first the data will transfer from your secondary memory to your main memory. First the data will transfer your secondary memory to main memory, and after that the CPU can access your data or it will execute your instructions. Okay. Now we'll see about the main memory or primary memory. Okay. how the memory look like. Okay, so memory means basically it will the collection of different cells. Okay, it will look like that. This is a collection of different cells. These are the different cells present in your memory. The size of each cell is fixed. The size of each cell is fixed. So, as for example, the size of this cell is normally it will come under 1 byte. 1 byte. Okay, this is a collection of cells. This is a collection of cells, and size of this cell is either 1 byte, 2 bytes, or 4 bytes. The size of the single box is either 1 byte or 2 byte or 4 byte. That will totally depend upon your system. But in the computer programming, we always assume like that the size of each cell equal to 1 byte. 1 byte means that is nothing but equal to 8 bits. Okay, collection of 8 bits equal to 1 byte. Okay, collection of 8 bits equal to 1 byte. Same like that, 1024 byte equal to 1 kilobyte. Okay, or you can also say like 2 to the power 10 bytes. Okay. So if you are saying 1024 bytes equal to 1 kilobyte, or you can also say like that 2 to the power 10 bytes. 1024 kilobytes equal to 1 megabytes. Okay, that you can also write 2 to the power 20, 2 to the power 20 bytes. Okay, 1 MB. That is also called the MB, and you can also write the 2 to the power 20 bytes. Same like that, 1024 megabyte equal to 1 gigabyte. 1 GB, you can also write 2 to the power 30 bytes. We are not writing bits. Bits, the symbol is small b. Bytes, the symbol is capital B. Okay, same like that, we will go for 1024 gigabyte equal to 1 terabytes. Okay, 1 TB to the power 40 bytes. Okay, that we'll see. That we'll see. Just will wait. Okay, just will wait. Okay, so what we are writing here, 1 byte is equal to 8 bits. 1 byte is equal to 8 bits. 1024 bytes equal to 1 kilobyte, and you can also write 2 to the power 10. You can also write 2, because if you are going to solve the 2 to the power 10, you will get the same 1024. If you are going to find the 2 to the power 10, you will also get the same value 2 to the power 10. You will also get the same value 2 to the power 10. Same like that, 1024 kilobytes. 1024 kilobytes. Okay. I have already mentioned 1024. What is the value of 2 to the power 10? Anyone can tell you what is the value of 2 to the power 10? It will come 1024. So that's why we are writing 2 to the power 10. 1024 in place of 1024, we are writing 2 to the power 10. 1024, we are writing 2. Same like that, 1024 means 2 to the power 10 into 2 to the power 10. What value will come? Anyone? 2 to the power 10 into 2 to the power 10, it will come 2 to the power 20. So we are writing 2 to the power 20 bytes. 2 to the power 20 bytes. Okay. Now here you can see. Now here you can see we are writing here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Can you tell me what is the total number of cells present in this memory? What is the total number of cells present in this memory? Anyone? Can you tell me what is the total number of cells present in this memory? 11 or 12? 12. Can you tell me what is the size of this memory? If the total number of cells equal to 12 and the size of each cell equal to 1 bytes, so can we say the size of this memory is 12 bytes? Can we say the size of this memory is 12 bytes? Okay, can we say the size of this memory is 12 bytes? Okay, basically this cell, each cell has some unique address. It has some unique address. So as for example, 0 is the address of this cell, 1 is the address of this cell, 2 is the address of this cell, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so these are called the address of the cell. Okay, so this is a memory. Memory basically contain what? It will contain the data, and basically we are performing the two operations on memory. One is called the write operation, and second one is called the read operation. In the write operation, what we are passing? We are passing the address as well as the value. Okay, so as for example, if we are writing write, say instruction, we are giving one instruction like that, write 5, 7. What do you mean by that? We are giving one instruction to write 7 in the address of 5. Where is the 5 address? This one. So we are going to store 7. Same like that, we are going to execute the read instruction, we can only pass the address and it will return you the what is the value present at that location. What is the value present at that location? So if you are writing read 8, what is the value present at that location? Some garbage value, because by randomly some value is already present in this memory. So you can see like a garbage value. If you are writing read 5, what is the value present at 5th location? Anyone? What is the value present at 5th location? Anyone? 7. So we have to write 7. We have to write 7. Okay. Now here you can see. This is the very, very important one. You can see. Okay. I have already mentioned, just you can see, I have already mentioned if the number of bits, no, we cannot say null, we can say some garbage value, because automatically some value is already present in your memory. Some value is already present in your memory, so that we can see as a garbage value. Okay. Read means we are going to write the simple concept. Read means you are writing the read operation, read, and then you are giving the address. So, as for example, 7. Now we have to check what is the value present at 7. Okay, so we are writing read 7, and it will return you the value. Same like that in the write operation, that will take 2 values. One is called the address, and second one your value. So first one your address, where you are going to store this value. So this is the address we have to store this value. Okay. Now here you can see this is very, very important. Okay. If the number of bits, I'm not talking about the bytes, if the number of bits equal to n bits, what is the maximum value we can store? What is the maximum value we can store? Anyway, what is the maximum value we can store? I have already mentioned 2 to the power n minus 1. Clear? Maximum value we can store 2 to the power n minus 1. Okay, 2 to the power n minus 1. Now the question is, if the number of bits equal to n, what is the maximum different value we can generate? Maximum different value. If the 2 bits, what is the maximum different value we can generate? 0, 0 is 1 value, 0, 1, 1 is 0, 1, 1. So maximum how many value we are generating? 2. So if there is n bits, maximum can be write 2 to the power n. Can we write 2 to the power n? Can we write 2 to the power n? Up to here, anyone, any doubt? Up to here, anyone, any doubt? If you have any doubt, then I will explain. Simple concept. We are talking about the simple concept. Okay. Now, when you are working in your computer, it will always start from this is just like a numbering. This is just like a numbering. Now we'll see how we are writing this. Okay. So in your computer system, there is one bus, or also called one wire, something like that, or you can also call that a bus, and that is called the address bus. Okay, address bus. That will only contain the address. That will only contain the address. Okay, or you can simply assume like an address. Address means address of your memory. Address of your memory, and that will only in the terms of 0 and 1. That will only present in the terms of 0 and 1. Okay. Now, if you are using your RAM, try to understand. This is your RAM or your main memory. Okay. This is your RAM and your main memory. Okay. If the address bus containing only 3 bits number, 3 bits number, okay, 3 bits number, only 3 bits number, the address bit containing only 3 bits number, okay, or your RAM is only contain the address of this RAM is only 3 bits. The address of this RAM is only 3 bits. Can you tell me what is the different address we can generate? What is the maximum different address we can generate if the address of this RAM is only 3 bits? So maximum we can generate 8. Okay, so we can write something like that. 0, 0, 0 is the address of first one. 0, 0, 1 is the address of, because each cell has unique address. 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay. So total 8. This is your 0, 1, 2, 3, 4, 5, 6, 7, something like that. Clear? Okay. Now you can see the same like that. You are using your system called 32-bit system and 64-bit system. Okay. Nowadays, sometimes you are using the 32-bit system and sometimes you are using the 64-bit system. Okay. If you are using a 32-bit system, what do you mean by that? The size of this address is your 32 bits. The size of this address is your 32 bits. Can you tell me what is the maximum number of address we can generate? What is the maximum number of unique address we can generate? 2 to the power 32. Can we say 2 to the power 32 is nothing but equal to 2 to the power 2 into 2 to the power 30? Can we write? Can we write 2 to the power 32 equal to nothing but 2 to the power 2 into 2 to the power 30? And can we write this is nothing but equal to 4 megabytes? Okay, 4 gigabytes, 4 GB. Can we write this is nothing but equal to 4 GB? Okay, 4 GB. So whatever the address it will generate, just try to listen. Whatever the address, the 32 bits address it will generate, the maximum it will generate 2 to the power 32 different address. It will generate 2 to the power 32 different address. Okay, size of the each cell is already fixed 1 bytes. Then in this case, if you are going to find the total value, or if you are going to find the total size of the RAM, is your 4 GB RAM. If you are using the 32-bit system, it will only utilize the 4 GB RAM. It will not utilize the rest part of the RAM. Either you are using the 16 GB RAM, or you are using the 8 GB RAM, or you are using the 12 GB RAM. And if you are using 32-bit system, it will only utilize the 4 GB part of RAM. Now the question is very simple. Okay, maybe some students have done. Okay. Now we took that this is your memory. Try to understand. This is your memory, and here we are using the 4 bits. In our memory, 4 bits address is there. 4-bit address is there. Okay, 4 bits address is there, and the size of each block is your 1 byte. Can you tell me what is the size of this RAM? Anyone? What is the size of this RAM? You are using the 4 different blocks. What is the size of this RAM? Anyone? What we can write here? Different number 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so last one is 1, 1. Now we'll tell you what is the maximum different address we are generating. 1, 2, 3, 4. If you are going to count total, it will come 60. It will come 60. Size of each cell is fixed 1 byte. What is the size of this RAM? What is the size of this main memory? 16 bytes. Okay. Now we are using one system, but the address size is only 3 bits. Address size is only 3 bits. Okay. What are the unique address you will get? The address size is only 3 bits. What are the unique address you will get? Either you will get 000, 001, 1, 010, 0011, then 100, 101, 110, 111. You will get only this 8 unique address. So if you are saying like that, read the instruction present in address 001. That is something equivalent to this one. It will not consider the first one. It will start from this side and it will only consider the third part. Can you tell me if there is any scenario where we will read this address? If there is any scenario where we will read this address, what I'm saying, just you can see. Now assume that you have brought one RAM. Okay. The address in your RAM is 4 bytes. Okay, 4 bits. Okay, means you can easily calculate what is the total number of cell in your RAM. Anyone? How to calculate? What is the number of unique address you can generate? 16 unique address you can generate. So there are 16 cells present in your. Okay, size of each cell is your fixed. That is your 1 byte. Size of each cell is your fixed. That is your 1 byte. So what is the size of whole RAM? The size of whole RAM is your 16 bytes. The size of whole RAM is your 16 bytes. Because when you are buying the RAM, it will also mention like that 64 into 1 byte. 64 is the number of cell and size of one cell is your 1 byte. When you are buying this RAM, you will get this type of information. Some case you will get something like that 1024 into 2 bytes means the total number of cells equal to 1024 and size of each cell equal to 2 bytes. The size of each cell equal to 2 bytes. But in this lecture, we are always going to consider as a size of each cell equal to 1 byte. But in the real life, you can also get 1 byte, 2 byte, and 4 bytes. 1 byte, 2 byte, and 4 bytes. Okay. Now you can see. Yeah, number of unique address equal to number of cells. Number of unique address equal to number of cells. Okay, as for example, simple. Now we do that. You are planning, or in your college is giving some ID. For each student, the college is giving some ID. Okay, in the decimal number. Okay, they are using only 3 cells. They are writing these types of cells. Okay, where they can write some decimal number 1, 2, 3, 3, 1, only 3. Can you tell me what is the maximum number of students the college can take? What is the maximum number of students? What is the maximum number of students? 1000. It will not take more than 1000. Why it will not take more than 1000? Anyone? Why it will not take more than 1000? Because its range is, you can only write 0 to 999. Same like that here. Also, if you are saying the 4 bit, means only the possible value 0, 0, 0 to 1, 1, 1, 1. Okay, and that value is coming 0, and this one is 15. So total number of unique values we are going to find, that becomes 60. Okay, 60. Now here you can see. So I have already mentioned. So in this case, if you are using the 3 bits, the rest address, whatever the address present here, whatever the cells present here, your CPU is not going to utilize this cell. Okay, so previously, if you are going to the past 10 years, then previously we are using the 2 GB RAM, or maximum we are using the 4 GB RAM. Okay, that's why we are using the 32-bit system. But nowadays we are using the 64-bit system. We are not using the 32-bit system. We are using the 64-bit system, so that you can effectively utilize your RAM. Because if you are using the 64-bit, the size of the address is 64. It will generate 2 to the power 64 different address. It will generate 2 to the power 64 different address. Clear? So now I have already mentioned. So your main memory divided into cell. Each cell has unique address, and the size of the cell is also fixed. Okay. Now the next part is also very important. Now you can see, if you are writing, this is your main memory. Okay. And I'm going to consider the only 8 cells are there. 0, 1, 2, 3, 4, 5, 6, 7. Clear? Okay. How to write this one? 8 into 1 bytes, because the size of this cell is your 1 byte. Okay. Now we are using a simple term. Okay, that we'll discuss more detail during the number system. Okay. If you are going to store integer, simple integer value, you already know integer with 0, 1, 2, 3, something like that. That's your integer. Your system will take 2 bytes of memory to store integer value. If you are going to say the system to store integer value, it will allocate 2 bytes of memory to store your integer value. Okay. 2 bytes equal to how many bits? Anyone can tell me 2 bytes equal to how many bits? 16 bits. Okay. If the size is 16 bits, what is the maximum integer you can store? Maximum integer 2 to the power 16 minus 1. Can be right? The maximum integer you can store 2 to the power 16 minus 1. Okay. So as for example, now we can see we are going to talk about one integer 1 and 0, 1, 1. Can you tell me what is the decimal value? What is the decimal value? What is the decimal value? 1011. Anyone? Base 2. What is the decimal value? Anyone? 11. Okay. You can also see like that. 1 plus 2, 3. 3, 4 is not there. 8. 8 plus 3, 11. Okay. Now we are giving one instruction to write 5, 2, and 11. Okay. But I have already mentioned, because this is your integer value. This is your integer value. What is the memory it will require to store this integer value? Anyone? Can you tell me what is the memory required to store this integer value? Anyone? 2 bytes. Okay. What is the size of each cell? What is the size of each cell? 1 byte. The size of each cell equal to 1 byte. Then in this case, how it will store? Just you can see 1, 0, 1, 1. 1, 0, 1, 1. If you are writing in terms of 2 bytes, how to write 0, 0, 0, 0, then 0, 0, 0, 0, and 0, 0, 0, 0. If you are going to put 0 before the number will not change. Same like that. If you are writing 75, 0, 75, 0, 0, 75, 0, 0, 75, can we say all are the same number? Can we say all are same number? Yes. Now you can see it will store here 0, 0, 0, 0, 0, 0, 0, 0. In the next cell, it will store 0, 0, 0, 0, and 1, 0, 1. Okay, why it is storing in 2 cell? Because I have already mentioned the integer will take 2 bytes of memory, so it will take only 2 bytes. But if you are going to find what is the address of this, what is the address, that will only return the base address, that will only return 5. If you are writing 5, means that will contain the address of both cell. It is not necessary to return the both value 5, 6. It will only return the base value 5. It will only return the base value 5. And for example, if you are writing the read instruction, read 5, means you have to read what is the value present in fifth. First, it will check what types of value you are going to read. What types of value you are going to read? No, you are going to read integer value. That's right, sir. What I'm saying. Now assume that. Now assume that. Simple. Simple. Okay. What I'm saying like that. Okay. Simple. That we have written 0, 0, 0 because we have taken the 11. We have taken 11. Okay. Now here you can see what we are saying. This is the base address. Okay. Okay. Now you can see what we are going to do. How we can take some example. Okay. In your college, you are coming to the college hostel. Okay. This is a hostel number 1, hostel number 2, hostel number 3, hostel number 4, 5, something like that. Okay. And each hostel has some rooms. Okay. Now assume that this is a hostel that will contain some rooms. Okay. These are the rooms present in the hostel. Okay. These are the rooms present in your hostel. Okay. Integer, that is a by default. By default. It is standard. That will take 2 bytes of memory. Okay. Some case it will also take the 4 bytes of memory. That will totally depend upon your compiler. What types of compiler you are using. Okay. So either it will take 2 bytes of memory or it will take 4 bytes of memory. Okay. Now assume that the college is going to allow one single student can book 2 rooms. One single student can book 2 rooms. Not the 1 room, 2 room or the beds. Something like that. The college is giving the bed. This is a bed 1 and 2. Each room has 2 beds. Okay. 2 beds. Okay. 2 beds. Now we'll tell you, if the college is going to allow one single student can live in single room, okay, you can book one single room, okay. Now in this case, what is the address of you? What is the address of the student? Anyone? Can we say the room number? Can we say the room number basically contains the address of the student? Can we say? Because in this room there are 2 beds are there, but the college is going to allow the single bed for all the students, means single room for all the students. When the college is going to allow the single bed for all the students, then in this case what we can say, the room number as well as the bed number. But in the previous case, when the college is going to allow the single bed, we are only giving the room number or we are not giving the bed number. Same like that here also, if this integer is taking 2 bytes of memory, they are not required to give the second address. We will only give the first address because it is always stored in the continuous memory allocation. It will not stored in the discrete. It's not like that. Some part it will stored here and some part it will stored here. It is not like that. It will always stored in continuous memory allocation. If you are reading read 5, if you are giving one instruction called read 5, first it will check what types of value you are going to read. Integer. Integer will take 2 bytes of memory, so automatically it will read whatever the content present in this 2 cells, whatever the content present in this 2 cell, and it will return in the value. It will return in the value. Same like that. If you are writing read 6, okay, what value it will return? Anyone can tell me what value it will return if you are writing read 6? What value it will return? Anyone? What value it will return? It will return you the garbage value. It will return you the garbage value because already they know you are going to read some integer value. It will take 2 bytes of memory. It will read these 2 cells, and some garbage value is already purchased, some value is already purchased, something like that. Some value is already purchased, something like that. So this will become your garbage value. Okay, this will become your garbage value. Okay. Now one student is asking why we can store maximum 2 to the power. Okay, how we can store 2 to the power 60 greater than 2 to the power 60? That we'll discuss. That we'll discuss. At that time, we are using the different type. We are using the different type. Okay, we are using the long integer or we are using the short integer. I'm saying 2 bytes. 2 bytes means not like the 16 bytes. I'm not saying R6 will return null. It will return some garbage value. Okay, simple. Okay, last example. Last. Now you can see. After that, your concept becomes clear. 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now we are taking the integer. How we are getting the integer will take 2 bytes because based on the compiler, we are getting like that. If we are going to create any integer or if we are going to store integer, it will take 2 bytes of memory. Clear? Some case it will also take 4 bytes of memory. Okay. Now you can see. Now assume that this your memory some value is already purchased 0, 1, 0, 0, 1, something like that. 8 bits value 0, 0, 0, something like that. 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0. Some garbage value is already purchased, some garbage value is already purchased, some garbage value is already purchased. Okay, this is your memory because some values automatically some. Okay, that is in the terms of 0 and 1. Okay, now you can see. Now you can see. Just wait. Okay. Now, first we are giving one instruction like that. Write 11. Okay. Write 511. Okay. Means you are going to give the instruction to write 11 to address number 5. What do you mean by 11? 8. We are not taking 4, 1, 1. This is the binary representation of 11. Okay. But I have already mentioned that 11 will take 2 bytes of memory. This is a single 1 byte, 2 byte, 3, 4 bytes. We are saying this total equal to 16 bits. Can we say 2 bytes equal to 16 bits? Can we say 2 bytes equal to 16 bits? Okay. Now we show that we are going to save this one. So what value will it store? Because this is a garbage value and no one is using this memory. So now it will store 0, 0, 0, 0, 0, 0, 0, 0. And 6's number cell it will store 0, 0, 0, 0 and 1, 0, 1, 1. Okay. Now I do that the next cell the value is purchased 0, 0, 0, 1, 0, 1, 1. Right? Okay, next value is also purchased. But that is something garbage because that is not important for you. This is only your memory. This is only your memory. Okay. Because the integer is taking 2 bytes. Now if you are writing the read instruction, read 5. How it will read? First, it will check what types of value you are going to read. You are saying, I am going to read integer value. Okay. Now, the compiler has already idea the integer will take how much memory? 2 bytes of memory. Then it will take all the content present in this 2 cell. It will convert to the decimal number and it will return 11. Clear? Now, we do that. You are saying, read 6. Read 6. Okay. What will happen like that? First, it will check what types of value we are going to read. You are saying integer value. It will read this content. Okay. What value it will read? 0, 0, 0, 0, 1, 0, 1, 1, 0, 0, 0, 0, 1, 0, 1, 1. Can you tell me what is the decimal value of this number? What is the decimal value of this number? Okay, after that, now you can see it will only generate that much location. It will only generate that much memory, that much address. It will not generate beyond that. Now we'll tell you what is the decimal value. Anyone? What is the decimal value of this representation? Anyone? Then use your calculator. What is the decimal value? This is up to here. You are getting A. This is your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 to the power 11, 2 to the power 11 plus 2 to the power 9 plus 2 to the power 8 plus 11. So what is the value of 2 to the power 11? 2 to the power 11, anyone? 2 to the power 11, what is the value we'll get? 2048 plus 2 to the power 9, 512 plus 2 to the power 8, 256 plus 11. What value it will return? Some students have already given. What is the total value? What is the total value? Anyone? 2827. Okay. What is your expectation? Anyone? Can you tell me? What is your expectation? You are expecting like that it will return you 11 value, but it is returning the 2827. Can we say this is a garbage value? Can we say, because this value is not important for you, so we can say this is a garbage value. Garbage value is something other value you are getting. That is called the garbage value. So you are getting the garbage value here. Why we are getting the garbage value? Because we have given the wrong address to the compiler. We have given the wrong address to the compiler. That's why we are getting the garbage value. That's why we are getting the garbage value. Okay. No, I have already mentioned. The compiler will decide the size of the integer. The compiler will decide the size of the integer. Okay, the compiler will decide the size of the integer. Okay, if you want to store in 7, it will not store. Just you can see, you are not going to want. Just you can see in these types of memory, you are only giving the instruction. You are only giving the instruction to write my data. Write my data. The compiler, the system will decide where they are going to write your data, where they are going to write your data. Based on the ability of the memory, they will write the data in your system. If there is no memory available, some data they will write here and some data they will write in your hard disk. Some data they will write in your hard disk. Yes, we have to mention the data type. That's why in the C compiler, you will see if you are going to create any variable, we have to write the data type of variable. Int A means you are going to create integer variable. You are going to create one integer variable. Clear? Okay. Now we'll see the working procedure of this whole CPU system. If you are talking about the CPU system, it will take the two parts. One is called the ALU and second one is called the control unit. Okay, and after that, this is your main memory. We are talking about the main memory, and this is your some external device. Some external device. Okay, here the control unit is basically responsible to execute the whole instruction. As for example, if you are writing here summation of two numbers, right? You are writing summation of two numbers. That we'll see how we can read without knowing the serial number. Okay. Now you can see if you are writing here A plus B, you are going to execute A plus B. Okay. Means first you are asking the user to enter the value of A, then enter the value of B. You are finding the summation of A plus B, and then you are going to execute. Okay. Now, in this case, how the system will perform this operation? So first, when we are going to execute this instruction, first the control unit will check. Control unit will send one signal to check that whether this instruction A and B is present in your main memory or not. Whether this A and B is present in your main memory or not. This is also one important point. This is also called the volatile memory. Means once the system is off, whatever the data present in your main memory, that is going to delete it. That is going to delete it. That's why we are storing all the data in your secondary storage device. That's why we are storing all the data in your secondary storage device. If you are going to execute this instruction, first the control unit will send one control signal to check whether the data is present in your main memory or not. If the data is not present in your main memory, then first the data will transfer from your secondary memory to your main memory. This is a task. Okay. So first the data will transfer the secondary memory to main memory. And after that, once the data is available, then A plus B, then it will send one signal to the ALU, that is called the arithmetic and logical operation. That will basically use for the arithmetic and logical. Arithmetic means plus, minus, into, division. Logical means greater than, less than, greater than, equal to, less than, equal to, double equal to, and not equal to. Okay. So these types of operation done by the ALU. So then it will send one signal to ALU to perform these types of operation, to perform A plus B. Then ALU will perform this A plus B. It will store in your main memory. It will store in your main memory. And after that, you are using some external device, like you are using your monitor. It will return your value and it will print the value as a, whatever the value it is coming. If they say 5 plus 6, it will print the value as a 10. Okay, primary storage, primary memory is a volatile memory. Means once the system is off, then whatever the data present in primary memory, that is going to delete it. And this memory, every system or every program is using this memory only for temporary purpose, not for the permanent purpose. Okay, the permanent your program is stored in your secondary storage device, not the primary memory. Okay, so that we'll see more detail in the next class, arithmetical and logical unit and control unit. And after that, we'll start the important topic, that is your C programming, how the C programming will work. Okay, so this step we will start in the next class. Okay. No, secondary memory is the different one. You cannot say RAM and ROM both will come under the primary memory. Okay, RAM means read-only memory, and that is a non-volatile memory. RAM is random access memory, that is a volatile memory. Okay. So RAM and ROM both are come under the primary storage. Secondary device means your hard disk, floppy disk, pen drive. These are called the secondary storage device. Okay. Now one is to, yeah, if you have any question, then please ask. If
Sir?
you have any, yeah.
Sir, if you create a variable,
Yes.
will it be stored in the primary memory as long as
No.
our computer is on, or will it be
Just
transferred to the secondary memory?
Just you can see, when you are going to execute your program, then it will available in your main memory. When you are creating any program, automatically it will store in your secondary memory. When you are going to click the run, then whatever the data related to this program, that will available in your primary memory.
Will be transferred from the secondary to the primary memory?
Yes. Yes.
Sir, is our operating system also has to be stored somewhere, right, sir, when we shut down the computer?
That is wrong. Wrong. Some part of the operating system is stored in the ROM, not the RAM.
Okay, sir.
That is called the read-only memory. You can only read, but you cannot write. Okay, and that is also called the non-volatile memory. RAM is volatile memory.
Yes.
Cache,
Sir.
that we'll see. That we'll see in the next class. Cache is also primary memory. Okay, that is little bit faster as compared to your RAM. That we'll see in the next class. Yes.
So sometimes you're using the formula 2n minus 1 for the maximum value, and sometimes you're using 2n. So I'm not able to.
2n minus 1 is maximum value you can store how much, and what is the total number of value you can store 2n. As for example, if you are starting from 0, okay, and if you are taking single digit, what is the maximum value you can store? 9. Total number of value you can store 10. 0 is one value, 1 is another value, 2, 3, 4, 5, 6 up to 9. You are storing the 10 different value, but maximum value you are storing 9. That's why maximum you can store 2 to the power n minus 1, but total number of value you can store to n, 2 to the power n.
Yes, thank you, sir. So one more question.
Yes.
Sir, in the RAM, why is it called random access memory?
Because randomly you are going to access, randomly. If you know the address, directly you can access the data. If you know the address, directly you can access the data. It is not like that you will go for the continuous. It is not first you have to check the first cell, second cell, third cell. It is not like that. If you know the address, directly go to that address and we use that data. That's why it is called the random access.
Thank you, sir.
Yeah.
Next. Sir, I had one doubt. In the 32-bit operating system, you said that like maximum 4 GB RAM, we did it like that
4
2
GB part of the RAM will utilize. Maximum 4 GB part of the RAM will utilize. Okay. If you are using the 8 GB RAM, it will only use the 4 GB, means half of the RAM. It will not use the whole RAM.
So like for 64-bit system also we can do it like that 2:4 into 2:60.
So if you are going for 64 GB RAM, it will support up to, I think, the more than terabytes also.
Mm-hmm.
If you are going, it will generate the address 2 to 64. If you are writing 2 to 64 into 1 bytes, it will go 4096 GB. Now you can see one square have already given the answer. Even I think more than that, 4096 GB more than that also. Because 2 to the power 60, 2 to the power 60 just will calculate the value. It will come greater than terabytes also. 2 to the power 40 is your terabytes.
Okay, sir. Got it.
Yeah.
Thank you.
So BIOS is
Yeah,
ROM, right?
Sorry?
So BIOS is ROM, right?
Yes, something like that you can say. ROM means read only, that it will also come on the primary memory. That will contain some instruction that will help you to start your system. That will help you start the system. That type of instruction present in your ROM.
Modern computers do get updates for BIOS.
BIOS, I have no any idea about that. That I will check, then I will inform.
Sir?
Yes.
Sir, once can you briefly explain what a 32-bit system exactly means?
A 32-bit system, the size of the address is 32 bits. Size of the address is 32 bits.
So it's not the size of the cell, right, sir?
Not the size of the cell. Size of the address. Cell will come with RAM. Not the address is basically the CPU is going to create the address. When they are going to need some data, it will create some address. Okay, and the size of this address is 32 bits.
Sir, both the address and the value stored in the cell are in binary format, right, sir?
Yes, the address is also binary and value is also binary.
But the address doesn't consume any space inside the cell, right? So it's only the value which takes
It's only
up
the
all
value. That is only the instruction. You are giving one instruction like that. Just read the data present in the cell number 5.
Yes, sir. So like where is the address stored then, sir?
Address not stored. No address it will not store. Okay.
It keeps
Why
changing.
we will store the address? Why we will store the address? There is no any requirement for storing the address. Okay. When you are going to execute the program, the CPU will decide where you are going to store this value. Okay, I've already mentioned that. Initially the program is present in your secondary memory device. Okay, and when you are going to start your program, the CPU will decide where we have to store this value. Okay, then the CPU will give you one instruction like that address, and you have to store this value to this location.
Yes,
okay,
sir.
and that how they will decide based on the abilities. As for example, if you are booking the room in hotel, first they will check. First, we will check the status of the hotel, and based on that, they will give you one address. That will give you one room number. Okay. If the room
Yes,
is
sir.
available, it will give you a room number. Okay. But they will not store any room number. They will give you the room. First, they will check all the list, and they will give you the room number. Okay. Now you can see like that. If the room number is 2 bits, if they are giving the room number in binary format, what is the maximum number of room in that hotel? 3 rooms. 4 rooms, maximum 4, because first room ID 00, second 01, third one 10, and fourth one 11. If your hotel is 8 room, you cannot utilize the rest 4 room because you cannot give the unique address for the rest 4 room.
Yes, sir.
That's why I'm saying, yeah. Cell size I have already mentioned. In this lecture, we will consider the cell size is 1 byte, but in the real life, the cell size is your 1 byte, 2 byte, and 4 bytes. 1 byte, 2 bytes, and 4 bytes.
So like in the 32-bit operating system, like suppose if we are storing an integer of 16 bits, so one cell will be enough, right? Like
No, 32 bits have what I mentioned. 32 bit means the size of the address. Means whatever the CPU will generate, the address, that size is 32 bits. Okay. Now, if you are talking about the RAM, where the cell size is 2 bytes, then it is fine. It will store in a single cell.
okay, sir, got it.
Don't mix up with this address to your cell. RAM is the different part, address is the different part.
Okay, sir.
Sir?
Yes.
Sir, so if we have a 32-bit system, it doesn't make any difference whether we have a 4 GB or an 8 GB RAM?
Yes, it will not make any difference.
Okay, so but now most systems are 64 bits.
Yeah.
That's why we can take any amount of RAM. It'll increase
Yes.
the performance.
Yes.
Okay, sir.
Anyone? Any doubt?